So we've gone through an example assessment where we pick a single server, we do some scans, we collect some information, we upload it to the server, we have some findings, we create a report along with a narrative. Let's go through some other features that the server has. So here's our session that we have. So we've gone through the overview. This is the overview. We have a list of hosts. We have our list of services. There's our findings. There's our report that we generated, our narrative builder, uploaded files. We're back to the session list. We've created a session before, and we've gone through the downloads page. Next is the CVE section. We're able to accumulate CVE data. These are known vulnerabilities, and do searches on those. If we go through the admin dashboard, we can see our CVE data right here where we can manage it. Right now there's no data, so we can do a full update, download all CVE data using this button right here. And then we'll take the description and also create embeddings for it for semantic data. Okay, so the CVE database is very large, and it will take about 24 hours to do a full load of that database if we're starting from scratch. So typically you would start the server, it would run about 24 hours, and then just to load up that data and then create all the embeddings for it. So that's why it's put into the persistent database, because it's going to be a one-time thing that you'd run. What I've done is I already have that data populated, so I've already replaced the persistent database here, and I'm going to restart our instance. I'll check our database, see if this can connect properly, and we found 315,000 CVE entries, so quite a bit. And then our control panel for the CVE database is here. So we can do a new update if we like, and if we're starting from scratch, we do a full update here. Looks like it's updated to partly 2026. Okay, so it's about a month behind, so let's just do a quick search. Look for anything with IBM. For the last year. Here we go. Okay, so there you go. These are all CVE findings from IBM. Descriptions are typically a bit sparse, but if we find the CVE, we know that a user has this, we can add this to a finding as well. So there's our session. Added to that session. Now we have a finding for that. There it is. We'll need to put a lot more information in it because those CVEs don't have a lot of information that comes with it. Next to the CVE link is the knowledge base. And this is also part of the persistent database as well. So this would carry over no matter how many instances you have. So just an internal knowledge base that a team can build on and can also add embeddings to, so that we can do a semantic search as well. Next we have checklists. We have a default checklist that comes with it, and we can build our own checklists as well. We can create new checklists. We can add and modify the checklist. But within the default checklist, we have, say, for example, PHP site. So we're going to look for, we have steps, commands, code blocks, things that we can add for looking for local file inclusion or remote file inclusion. So these are just some examples. Command injection, things of that nature. Postgres server, Active Directory, a lot more with Active Directory here. If we go back into our RTFMv2 client, we can see that we have access to those same checklists. So those are downloaded or installed by default, and then we can load our own set of checklists as well if we wanted to. Right here. We can load a new profile, and these are the same checklists that we saw online. And so we can go through here, here's steps, here's some commands that we can run, any kind of code that we could run, and then we can mark it, no, we're not done with this, we are done, or it's not applicable. Also, along with the checklist are mind maps. And mind maps are more of a tree as opposed to a step-by-step process. And the mind map I have as an example is for Active Directory. Let's see. More of a step-by-step process, enumerate, LDAP. Here's some commands that we can run. Any node can be marked as done. Any node can also be ran as a command as well. And then we can edit this. And we can enter our host and then execute it. Once we open it up again, that progress is also saved. And same thing with the checklists, those are saved. It's also committed online so we know what users have done what with what checklists. And it's also applicable to, also helpful when we have a custom checklist for a website that has custom features that we may want to test, things like that. It also can be a collaborative tool as well so that the team could make their own checklists. So after the checklist, we have code snippets. Very similar. We have a set of default code snippets. Most of these are just reverse shells. It's also templated, so when we load it in the client, we'll have our target and our port already specified, or at least the target will. We may need to specify the port manually. So these are all just common reverse shells. To view the code snippets, we just look in the workshop code snippets, and they're categorized as well. These are the same code snippets we saw online. Okay, so we would enter our target, and then we would specify the port. Apply changes. It's ready to copy and paste. Next to the code snippets, we have commands. Same thing, there's a default list for Windows and Linux. The Windows one doesn't really have a whole lot because Windows is not really a good platform for attacking. But these are mostly tools that come default with Kali. And then this will export into a JSON file, which is loaded whenever the client loads. Then in the client, all of these are what's represented in that JSON file. So that all of these commands and all the commands in here are data driven. After the commands, we have embeddings. This is more for if we wanted to upload documents, create embeddings, and then later do searches on those embeddings, but this is still very beta, so not quite ready. Then we have downloaded data. This is also in the persistent database, so it never goes away. We have our default checklist, default shells, default tools for Windows and Linux, mind maps if we wanted to share mind maps, don't have any in there by default. And then we have a bunch of files that are persistent as well. This is actually part of the Purple Team plugin, which I'll show in a minute. But any data that's persistent within these plugins is also inside the persistent files section of the persistent database. And then a Lua file. The file selection also allows you to do a preview, download, edit, that kind of thing. We can also edit this if we wanted to. So let's move on to the plugins. Plugins helps you extend the functionality and customize RTFMv2 server to what is specifically needed for the team. So example, I have a Purple Team plugin here. Just has a bunch of scripts I use for Purple Team engagements like data exfiltration, things of that nature. Most of the pages that have more advanced functionality will have a Lua editor. So I'm going to import a number of scripts into the Purple Team plugin. Here's my C data. I've got a number of scripts in here for both Linux and Windows. And I've got a script ready to go. It's going to read the data, populate it. Here we go, imported 194 scripts. Then we'll go back in there. There you go, there's our scripts. After that, we have a code review plugin that I added where I can just, in times past, I've needed to paste code in here, check if it was vulnerable, also give me a suggestion for a fix. And then I can check the history of it and then also assign a specific AI provider for it. Agent loadout, nothing special here, just more about commands on how to create a OpenClaw style agent for specific tasks. This is a test user plugin, just very simple, shows example of how to enable and disable plugins. And then we can also manage these plugins in the admin dashboard here. Load them, reload them, disable them, any issues that we've had. The C2 plugin is a bit more sophisticated. I wanted to put this in a plugin because RTFMv2 server is designed, or its purpose is to collaborate data. It's not meant to be an attack surface. But I needed a command and control system, and it made sense to add it into the server since clients, our RTFMv2 clients, connect to it, so it just made sense. So this is just a command and control system that I've set up before. Let's create a listener. We'll just do HTTP 2. We can point it to a specific session if we wanted to, and it would just log commands for that session. And it doesn't have to be assigned to a session either. Okay, so we have it running on port 8888. We can create a agent for it. Here's our listener. We'll do C#. Actually, let's do a Python and we'll run it in our Linux demo. Let's do a check-in every 5 seconds. Okay, I'll copy this over to our Linux machine. All right, over on our Linux machine, we'll just go ahead and run the agent. Okay, and back on our server, we see that we have Kali connected already. It automatically it runs a command called features, so it tells us what it's able to do. Here's the commands that it can run. Let's give it a task. There's our agent. We'll just run, who am I? So it's pending because by default, we have to have permissions to send commands. We'll just auto approve all of these. And we still need to manually approve that one. Okay, so it did complete. It says we're root. So in here, there's different payloads that we can do as well. If we select a compilable language, we'll have C#. We can tell it we want the source code or we want to compile it into an executable or a DIL or shellcode. And we can pick the platform and architecture. Otherwise, if it's a scripting language, we won't need to do that. So next, on the admin dashboard, number of things we can do. We can auto install SSL certs or TLS certs so that we don't get the warning message when we try and load the page. I usually don't worry about it. User management, we've already seen that. Database management. So if I'm done with an assessment, I can go ahead and archive it. There's our archive. And we can load that as well. So if we ever wanted just to have one session in our session list at one time, we could always do that. And then we can later on archive that. And if we have multiple servers running on different machines, we can actually go to the session manager here. Here we go. And then we can actually copy. Let's see. Nope. We can copy this to another server. So we can have a remote hardened machine that's meant just to archive sessions if we ever wanted to. And this instance could run more in an engagement scenario, even on an attack surface if we wanted to. And then have a safer version that we archive later. System logs. Okay, yep, had some plugin issues. There's our CVE database. AI options we've already seen. Finding sections. This is similar to the report section where we can turn on and off different sections that you'd put in a finding in the report. The same thing with the report. Templates here. Then we can add Word templates here. Session Manager again allows us to delete sessions if we wanted to. We can copy them over. APT server, we can only use this in Linux, so I can't show this. I'll have to show a Linux instance of this. But if you're ever running a Dropbox or just a Kali instance and a company has cut off communication to your traditional APT servers remotely, which is a very common scenario, this will create an interface that you can host your own Debian packages, so you can bypass that. Node-RED we'll cover later, but it's support on interacting with RTFMv2 Console through Node-RED. Notifications, we can trigger notifications based upon, we can send out emails and things of that nature if we ever wanted to do that. Job scheduler, we can have jobs set up at certain intervals, times of day. We can do, say, for example, backups. We can run Lua scripts. A lot of Lua, it's very Lua driven. A lot of Lua examples here that we can run. It's very tightly integrated with Lua. And then we have a Lua editing page as well. So built-in modules here, built-in scripts that we have, and then we can run more sophisticated Lua scripts if we wanted to. Here's our output, some environmental variables. We can set environmental variables through Lua as well. Worker pools is still in beta right now, but it's looking very promising. What this will do is it'll allow us to run multiple instances of the console version on different machines. And then we can register each console as a worker, and each instance, so this is each session has its own pool by default, and it's already enabled by default. So our session that we're working with has a pool ready, and we can register a console version or console with it and send out commands. So if I'm mapping out a network, that will take time, and there's a number of commands that need to be ran in sequence to map out a network. But instead of it all being done on the GUI client, we can send those commands out to those consoles as well. So very useful. This is our plugin management portal. Load, unload. We can build our own plugins as well. We have example code here and a skeleton project if we wanted to. And then if a plugin there's two different levels of permissions with plugins. A user level, which you'll see here in the sidebar. And if there's an admin level, then you'll see a card here. So going back to the RTFM client application, here's some of the features that it has. New and load existing sessions, application settings that we can have, session specific settings like HTTP word lists, user lists, proxy settings. If we're running this in Windows, this button would change. It would actually allow you to use WSL to run commands through WSL using the Kali distro if you have that installed. So you can run all of these commands from Windows as well. It's not, Windows isn't being used as an attack surface. It's using WSL. The only issue I've had so far is using TCP dump in WSL, which is a known issue. Our AI settings, we've seen this before. We can load custom tool sets, load custom code snippets, which is like our reverse shells that we had seen, and any downloaded files. We can download files from the server as well. This just forces a synchronized update with the server. This lists all the different processes that we've had. Any user accounts that we've had, and this is also integrated with some of the AI agents, like the web AI agent will give you an option to choose accounts if there's any accounts, and that'll try and authorize itself using those accounts. Remote consoles, which we'll cover later, but we can remotely access our RTFM console apps. So if we install a console app further into another subnet, for example, we'll be able to communicate and run commands from it. And then we can upload files to the server as well. This is all of the logs that we've queried the AI with. This has all been done in the background. These are all services found in this case. Any checklists that we've done, it'll come through here. So if we go through here and we've done this, and we've done this, close it. There we go. And we can output that into a report as well if we'd like to. And then the same thing with commands. List all the commands and the outputs that we've had. You've noticed that most of these windows will have a little icon here. This is simply to dock it here. So we can dock these windows, close them if we want, and we can also undock it as well. It also serves a purpose. It has a Lua scripting interface to it. So each window that has this icon, we can create scripts specifically for this window. And I just so happen to have a test Lua script that I can run. All right, so this is just a quick scan to show we can interact with the controls. And we can save our scripts as well, so we can pull them up later on. There you go. Okay, so next we have nuclei. Dock that window as well. And we'll come back when this is done. All right, so the scan's complete. Gives us our scan. This is, again, synced with the server. We have a better formatted feedback here. Raw output there. Next we have OpenVAS. The only reason we'd want to run it within here is so that we can collect the data, format it to what the server can read it for, and submit that data. That's all we do with that. Ping scanner is usually used when you have a range of IPs, but it'll help find hosts. So if you have, say, 100 hosts that you're scanning and half of them were not alive on day one, day two you come back, you do another scan, you'll find those IPs have changed. So once it sees that they're alive, it marks them as alive, and you can add more hosts to the list that need to be assessed. And then a number of integrated web tools, so Dell Fox. And we have a Wrestler API fuzzer. The API security testing tool. And you'll also see that these windows are checking to see if they're installed, and if the tool is not installed, it will do its best to install it for you. Let's see. Same thing with Wrestler, installed it for us. This is to examine TLS headers. SQL map. Web API viewer. So this will take an Open API JSON file. You'll see the list of available APIs, and it will actually run integrated tests on them. So fuzz them, SQL map. Every tool that we have integrated in here will be ran against those tools as well. wfuzz. And then an interface to Zap proxy. So I've just started Zap proxy. See here. We'll test the connection. We can connect to it. Oh, yeah, I didn't find anything because we didn't authenticate. Let's remove that. This will probably take longer. So I'll put this on pause. Okay, so it didn't finish the scan, but it scanned enough just to see what we have. We can see our findings here, and then the URLs that it discovers, and we can get the details. We can run specific tools on those requests as well. But here's our request, there's a response in the summary of it, and then within that request we can run specific tools as well. Okay, so let's take a look at some of the tools that we have. The agent manager is more of an interface to the existing agents that we have in our agent library. This is the web agent that we had interacted with. Also, we can load plugins as well. There's a few example plugins that I can show later on. This is all the Active Directory tools, and we'll need an Active Directory server to show you those tools, which we can do later. This is a tool that will help enumerate websites. MSF Venom, this is just a graphical interface to MSF Venom. Just nice to see all the different options that you have. And it builds the command as you go. And then you can run it yourself. Network Monitor, this is just a user interface to TCP dump. our console, this is more of a virtual console that is based around the tools that are already loaded in RTFM client. So we have all of our nmap commands here. And I'll just do a quick one. Okay. And then this also can interact with the remote console as well if we have any remote consoles, which is defined here. Terminal is similar, but it's just a raw connection to the OS terminal is all that is. So the difference between this is just it's a raw connection to a terminal. And the reason that you'd want that is every command is logged. That's why. Low bin checker. So when we're enumerating a machine, we can get a list of binaries that we have access to, whether it's on Windows or Linux. We paste it in here and it'll tell us whether it's part of the lol bin list. So if I'm doing local enumeration and I happen to have a list, I'll just paste that in here, do a check. There's some examples of how we can use that to further enumerate or escalate. Parser, this is just a list of all the built-in parsers that we already have. But in this case, if we say run a nmap scan from the console, we can just copy, paste that into here and it'll read it and give it meaningful data for RTFM so that we know, okay, here's some hosts that are live, here's some servers that are live, and then it would reflect within the application itself. It just helps with tracking if we ran tools manually. Just a user interface to help us establish SSH tunnels, and a interface for WinRM. So not only does the server have plugins, but the client has plugins as well. Here's a few example plugins. We have John the Ripper, and we have a command search as well. After plugins, we have AI. These are the same agents that we've seen before. We've got the API agent specifically just for web API. There's our web API that we had used earlier. There's an Active Directory agent as well that we use just to enumerate Active Directory. Our help section, we can submit a bug if we find a bug. This is also rendered when the application is going to crash, it tries to get a stack trace. This is our main scripting window. This is not tied to a window itself. So if we do, MSF if we do scripting interface, the code that we run here is specifically for this window, and it will interact with the controls for the MSF Venom payload generator window. This scripting interface, however, will interact with the entire application, and it's outside the confines of that window. And we have a number of different Lua scripts to demo that, along with some documentation. Here's the custom modules that we have. And then we have different scripts that we can use to manage. And then just a link to our online documentation. Okay, back to our Kali client, we'll go ahead and download the CLI version. And we'll make the console executable an actual executable that Kali can see. And we'll go ahead and run it. After we copy the license. There we go. So you can see we have a number of commands that are built in. Let's go ahead and first load the same session that we were working on with the GUI client. So we're just going to use the load command. There's the URL of our web server. There's our username. There's our password, and then the session name. Okay. And once I have the session loaded, you'll see that my prompt's changed. I'm going to register this machine as a pool worker, a worker in the pool. I'll show you what that means in a second. Okay, so now we've registered ourselves in this pool. I'll show you what that looks like on the server. We'll go into our session here. Oh, we don't need to. We'd go into the admin dashboard. Worker pools. Each session has its own pool. So there's the one session that we have, and there's the card showing the information for the console that just registered itself. And what this means is we'll be able to send tasks to this worker remotely so that we can help distribute some workload, especially when it comes to network mapping and things like that. In the GUI client, we'll be able to interact with that pool. So now we see that there's actually a green light up here. That tells us that we have at least one worker in our pool and we can interact with it. This sends out a command to the server every 30 seconds to see if we still have workers in the pool. If we need to run in a more silent mode, we can just turn it off by clicking this pause button. But what we would have is we'll have just a regular command, and we can just right click on the execute button and we'll send a pool. And what that will do is it'll actually send this command to an available remote worker so that we can offload that work. It's still in beta right now, so it's not quite ready yet. So let's explore some more features that we have in the client. So we're connected to our pool. Let's get some information on it. We have a number of options that we have also available in the GUI application. The reason that we'd want to put this in a console is so that we can automate this. So it's more clunky to type through all the features as opposed to clicking, but this will help us with automation. So we can check out the checklist commands, and we can list those commands as well, or list all the checklists. This is exactly what you'd see in the GUI application. And from there, we can narrow this down a little bit. There's our checklist just for the tunneling. You can see we've marked it as done. This is something that we wouldn't normally do manually, but again, this is scriptable. It's wrapped within an MCP layer, and it can be accessed through Node-RED as well. All right, let's take a look at host info. This is all the information we've collected on this host so far, all the nodes, services. And of course, we have access to the same number of commands. This is just a list of all the commands that you can run in the console, but these are also the same set of commands that you can run in the GUI as well. Let's list our templates. Same templates that you can run in the GUI. Our lull bins. Let's do a query. Let's do find. These are the things that we can do with the find command. We can run commands. And by commands, these aren't shell commands, these are commands that are within the RTFM framework. So these commands, so we just run them by name. And we can do save our session, list the sessions that we have. We can interact with the shell. So now we're in a Linux shell. We can do a manual sync. So we can sync our data to the server. We can run templates. This might take a little bit to run, so I'll come back when it's done. Okay, so we got that done. We've got a bunch of other options. We actually can use this as a proxy. We can also use this as a tunnel. These are also, we can use a tunnel on the GUI application as well. We don't have a proxy functionality in the GUI, so this is the only tool that can use this, be used as a proxy. We can also set up a WebSockets server. So let's see what that looks like. We can specify a port if we wanted to. The options are right here, but by default it'll just be on 5555. So let's see what that looks like on the GUI. So we go to sessions and remote consoles. Let's dock this. So we have our default IP right here. Here's our port. We'll just call this group 1 and we'll connect. So we are connected to that server, and I can open up a console that connects directly to that server. And from there I can run commands specifically on that server. And there's our connection. We're Bob. And we'll run one of our commands here, nmap ping. So that just is an example. We can deploy a console in different subnets, perhaps tunnel through or use a proxy to connect to it and run commands remotely and get that feedback back to the client. And then we can also save that from the console to the server, or the data that we get back to the GUI, we can sync that to the server as well. There are a few more other ways to interact with the console. What we can do is we can also interact with it using scripts. So Lua scripting, and then scripting specifically for the console. And we can use Node-RED to interact with it. And then we can also interact with the MCP server that comes with it as well. So let's take a look at what it looks like if we were to use Node-RED. So we go to our admin dashboard. We have a dashboard specifically for Node-RED. We can see that Node-RED is not installed, so we can go ahead and get that installed for us. And this may take a little while. Okay, so that didn't take too long, but we can see that it is installed. And we are actually connected to our Windows box, so we have a Windows directory here. Service is stopped, so let's see if we can go ahead and start it here. Okay, so it's running, and we'll go ahead and open it up. Okay, so we have custom nodes that we can use to interact with. We can run Windows commands, Linux commands, custom commands, create payloads, create a session, load sessions, the list command that directly correlates with the console, host info, template attacks. These are what we've seen in the console already. So we have a example flow. So from here we can create a session, we can load the session, run an nmap command, run a custom command. This would be like a shell command. Running a Windows command and getting output. So this is one way we can interact with the console in an automated fashion or in a GUI manner. Okay, so this was the last example I wanted to show. The console, again, is wrapped around an MCP server, so we can check and see. We have our tool here that's installed. This is Codex. I'm just going to ask it to go ahead and use the tool. There's our target, and go ahead and enumerate the target. That's going to use the tool, and we'll come back once it's done. Okay, it just finished up. It enumerated the server This is the Metasploitable server. One thing to take note that I noticed, it wanted to create some evidence bags because it found some obvious vulnerabilities. It wasn't able to because it's not set up with a remote server. So the RTFMv2 server is what hosts the evidence bags. We have a facility for the client to actually create and send evidence to the server, so it would have done that. And so it's aware of context. It has a context of what the server has. So maybe I can query a few things. Okay, there you go. And then we can request it to do other things, run other commands, whatever we want it to do. It's found very safe. FTPD. You really can't go wrong with Metasploitable 2 because pretty much every service is vulnerable. So, but it was able to recognize CVEs. So, good way to interface with the console.